If I could ask you to please take your seats, we're going to get started with our next session. It's a brief one. Thank you. So we have our second of two international missions sessions here. And our first talk is going to be given by Gwanghyeok from KARI, the Korean Space Agency. Gwang has been here at NASA Ames for a year's sabbatical. We're very fortunate about that, and he is our prime partner for our partnership with Korea. He's going to be giving a status on the Korean Lunar Exploration Program. So Gwang, please.
Good morning, everyone. I'm very delighted to give a presentation about the current status of the KPLO. And also, I'm kind of nervous because I'm basically aerospace engineer, so in front of so many prominent the scientists and lunatic over the U.S. continent. So anyhow, today I'm gonna talk about the Korean lunar program overview briefly, and then KPLO system and instrument overview, and then talk about some current project status and way forward. Actually, the Korean lunar program initiated by the previous President Park, who was impeached. So maybe you know that our new president came out. But however, the first phase is the Korean lunar program called the KPLO is still alive. And then so even though we got the official approval a long time ago, but we got started from last year. Which was composed basically stressing on the international collaboration, especially with the NASA, with so many support and additional the NASA payload from the U.S. continent. So finally, so our first phase overview is originally duration of only 3 years was given, but so we are now negotiating with our government to extend the launch date until the end of 2020, and then so but total budget was not cut so far. So maybe we are going to the allocation by year by year to be reallocated with an extension of the launch year. And so we will have the WMS is a 550 kilo class with about 40 kilo of the scientific payload and one technical demonstration payload. So many tasks is over here, including the building our own Korean DSN ground station antenna, which is 28 meter. Then so also we are going to implement some test bed for space internet, so delay tolerant network payload included. And additionally, we are undergoing to prepare the next lunar landing mission as a pre-phase A study. And this is a portfolio with a collaboration with NASA. Basically, we are going to lead the design and building and assembly and launch all together. Launch will be the international launch vehicle, not decided yet. But anyhow, so in the meantime, the NASA will support deep space network and operational, and then navigation support with the data archiving, and one additional scientific payload. So here is just some baseline. Actually, we had up to the end of last year, we had a SDR, System Design Review. So as of SDR, we keep still the KPLO baseline, so primary spec with the launch mass and power and mission lifetime. So also the mission orbit we are going to send our orbiter onto the lunar polar orbit, like LRO or the other international lunar orbiter. But however, due to the mass budget, we changed a little bit up to 150 kilo. But due to the insufficient of the scientific instrument requirement, so we lower down again onto the 100 kilo for the altitude. So inclination is 90 degrees. So also, but however, due to the weak heritage of the communication, especially deep space communication heritage of the Korean, the space technology, so we set up a little bit lower capacity of the S-band and X-band downlink and uplink capability. And pointing accuracy is 1.1 and ranging over the air. And here is recently almost fixed KPLO configuration. So its configuration has some updated since SDR with a 1 wing to 2 wing the solar array. And then you can see some instrument accommodation. Actually, due to the relatively short development history in spacecraft, only LEO and GEO. So far, mainly even with a big, relatively big camera or other scientific instrument, up to 100 kilo class, but quite a few payload, 2 to 3 was maximum for our LEO or GEO satellite. So now even the smaller payload, we have 6 payload. So our spacecraft engineer got such a mess, and very actually they didn't want to accept so many payload to organize together, so to give us some interface and to optimize the operational procedure, something like that. But anyhow, due to the several procedure, we finalized 6 payload, including one the technology demonstration payload. So that is a big the shadow cam originally from the Arizona State University is almost the 5 to 6 feet. And I'm going to tell you about some scientific objective one by one. For LUTI, will be built by CARI. So Lunar Terrain Imager is obtained the main purpose of LUTI is to make much more precise the terrain image for a possible landing site for Korean mission and others. And so the target observation is an interesting place on the moon. So we are looking for the possible location and doing some analysis. And also we are going to collaborate with internationally to participate by participating the several working group internationally. And the support cam is kind of some camera and a polarimetric imaging camera with two different face. One is at the face, and the other one is to find out titanium, the photometric and polarimetric the camera. And so we hope to that will be the capture the first polarimetric map for a near and far side of the moon. And the KMAG is kind of some highly sensitive magnetometer led by the Gwanghyeok University, who is very specialized on the lunar research on the magnetism and so lunar magnetic anomaly. They want to find and characterize the lunar magnetic anomalies and investigate the origin of the crustal magnetism of the moon. And KGRS is being led by the Gyeong Kim. So here, she will be present next time. So I'm gonna skip, and then anyhow. So the KGRS is a kind of a gamma ray spectrometer. It's that will be the map, the distribution of the major natural resource on the moon. And the shadow cam is mapping the several albedo pattern and other to provide some hazard and transferability of the information for the landing or landing rover by magnifying especially the permanent shadow region. So here is just a brief feature of the spec for each scientific instrument. The LUTI has a push-broom type camera. It's a linear CCD. And so total mass is less than 15 kilo. And GSD is 5 meter at the 100 kilo altitude. And then PolCam has only 3 kilo with a field of view is a 10-degree field of view. And the polarimetric, the wavelength is 430 and 650, and photometric is 32 nanometer. And KGRS is basically a gamma ray detector. So lanthanum bromide main detector and shielding up to the 10 mega electric EV. And so the total data the 25 up to 25 gigabit per day. And KMAG is led by Hojin, and then so they have some Fluxgate magnetometer sensor to measure the magnetic field close to lunar surface up to 70 kilo altitude. And NASA Shadow Cam by Mark Robinson at the ASU. So actually that design was heralded from the LRO NAC to magnify up to 500 times with a TDI detector. So they can have a resolution of 1.7 meter, especially onto the lunar pole.
1 minute.
Okay. And the other object, the science technology demonstration is called Space Internet. So we're gonna have a test the Space Internet payload up from the moon orbiter to the lander, the developed model for the lander on the ground in the Antarctica or other some analog field. So later on, we're gonna deploy additionally Space Internet onto our lander system to communicate and to provide the hub, the Space Internet, to robo or other the scientific instrument. Here is a ground segment, including the KPDS. And this is the site for the Korean the DSA site. We are going to refurbish the current existing 28-meter antenna to upgrade up to the DSN function. So this is a status update. We are going to have the PDR in the September, coming September. So most scientific instrument, except the shadow cam, is that they built up their engineering model or development model so far. So they're gonna have some separate PDR before the system PDR. And finally, the way forward. Actually, even though the shadow cam stress on the to reduce strategic knowledge gap by deploying this shadow cam, but Korean scientist or Korean the program manager has the weak the concept about the strategic knowledge gap. So we are going to implement, try to keep pace of the STG gap through the ISEC-G, and then so to contribute to internationally regarding to the science of the moon. And also we trying to reflect a Korean lunar landing mission to an international collaboration exploration mission to our National Space Development Plan to be updated by the end of this year. So that's all for my today's presentation. Thank you.
Thank you. Thank you very much. Yeah. So what